My name is Ravi Narayanan. I'm a product engineer in the ArcGIS Server portal team. And today I'm going to be talking about spatial analysis in portal and some performance and scalability considerations. So just a quick overview. I'm going to be talking about spatial analysis, what it is in portal for ArcGIS, and also about some of the performance and scalability considerations. Before I start, I would like to know how many of you have used spatial analysis functionality in portal or ArcGIS Online? Okay, just a handful. So it might probably be helpful to go spend some time in showing what spatial analysis is in portal. This is a functionality that we introduced in 10.4. It's been available in ArcGIS Online for a while, and in 10.4, spatial analysis is introduced in portal, and it brings equivalent functionality to your on-premises portal. It provides several tools that you can use with your portal and data in your portal for performing various analysis, such as aggregating your data, summarizing your data, or doing geo-enrichment, or doing any proximity analysis, like how many fire stations are within a certain distance, or what is my driving time between point A to X number of points. So I can do those kind of analysis. I'll quickly show a demo of what I mean here. So what you see here is a map viewer in portal, and I have a web map that has a few feature layers. I have developable locations, which is a feature layer for San Diego area, which has features representing areas that are assigned for specific land use, that can be developed for specific land use. And I have a layer which is a flood zone, and I have some fire station locations, and then I also have freeways. So if you have portal that is configured for spatial analysis, you will see this analysis button, which is over here in the map viewer. And if you also go to any of the feature layers, you will have this button for enabling analysis. So today, I'll just go through a short demo to show how I can use analysis in portal to pick a location for my warehouse in San Diego. So if I click on the analysis button, here it shows a list of category of tools that are available. You have tools for summarizing your data, where you can aggregate points by polygon, or you can summarize by nearby location, or summarize within a particular area. You also have tools for finding different locations based on the criteria specified. And you also have some hydrology and elevation tools. That's trace downstream is one where you can, given a particular point, you can find out, let's say if there is a spill in that location, you can find out where that spill will end up in a certain period of time. Data enrichment is another interesting tool where you can use utility services that's available in ArcGIS Online to enhance your data. You can get statistics about population or education or demographics. There's tons of functionality available there. And using these tools in analyzing patterns, you can find out hotspots or calculate density for your data. These proximity tools use network analysis functionality, and they provide you with tools for finding your nearest location or planning for your routes and so on. And this managed data category provides tools where once you have done the analysis, it lets you work with the data or export the data to a format that you can take elsewhere and use it. So for selecting this warehouse, I'm going to use this find location tool, and I'm going to use find existing location. So here I've chosen developable locations as the layer on which I want to find the ideal location. And here I want to find features where the planned land use is for a warehouse. In addition, I also want this location to be within a distance of 1 mile from a freeway. And in addition, I want this location not to intersect with a flood zone. And that's all. So I can provide a name. And then say run analysis. So at this point, I haven't created any GP tools or anything. These tools come with server, and once you have portal and server configured for spatial analysis, these tools are readily available for you. So what I did now, already it created the result data set. So this one, if I see it identified one feature, which it already zoomed into that location. So this is the feature it identified. So you can do further analysis based on the result it created. For example, from this location, I can find out if there is a spill in the warehouse, how it's going to travel, or what is my nearest fire station in case there is an event that needs to be handled, and so on. I can also do analysis like, how many people are within a 5-mile radius of this location who have a bachelor's degree, or how many people, what is the median income, for a 5-mile radius around this location. So if so you can ask interesting questions and answers and get answers from using spatial analysis. So that's just a brief overview. We'll go back to my PowerPoint. So how do you enable spatial analysis? You need ArcGIS for ArcGIS portal, GIS server, and ArcGIS data store. These are the 3 components that are required if you want to have spatial analysis capability in portal. Once you configure your server to be the hosting server and you register the data store with server, spatial analysis capability will be automatically enabled for you on a fresh install of 10.4 or 10.4.1. If you are upgrading to 10.4 or 10.4.1 from an earlier version, like 10.3, you will have to manually enable spatial analysis, which is a one-time operation. You will do it, let's say you're moving from 10.3.1 to 10.4, you'll have to manually enable spatial analysis. And once you enable it, any future versions you upgrade, analysis capability will be enabled for you. You don't need to repeat that. One important point to note here is if you have a portal with a hosting server that does not use ArcGIS data store, let's say you are using your own enterprise geodatabase as the managed data store for your hosting server, then spatial analysis capability is not available. So what powers this spatial analysis functionality? There is a spatial analysis tools geoprocessing service that runs on your hosting server. This service is started when you register ArcGIS data store and is registered as a helper service in portal when you enable spatial analysis capability. So as a system administrator, you would want to know, how many instances of this tool is running. By default, it is configured to have a minimum of 1 instance and maximum of 2. So if you want to increase the capacity of spatial analysis tools, you may want to increase the max instances on this service. You can access this service from manager if you're logged in as an administrator or publisher, and then you can increase the maximum number of instances for the service. One thing you may have to be careful is, this is CPU intensive, so you may want to make sure that you're not increasing this max instance to a number where you may not have enough CPU cores available. Other option is you could add additional machine to your hosting server side if you want to increase capacity. There are 15 tools that are available with spatial analysis out of the box. So once you install and enable spatial analysis, these tools are readily available for you. You don't have to do, you don't have to create any toolbox, or you don't have to publish any geoprocessing services. We already went through some of these tools. So these tools are standalone tools that run on your hosting server when somebody performs analysis. So one thing you want to note here is this will consume CPU and memory on your hosting server when you run these tools. So you have to plan accordingly, depending on how you anticipate analysis is going to be used in your organization. You need to plan for your capacity on your hosting server. There are additional 8 tools that are enabled after configuring utility services. Utility services are like helper services that power these analysis tools. And these utility services could come from either ArcGIS Online, or it could come from a server that you have in your organization itself. If you use ArcGIS Online, you have the option to configure hydrology, elevation, geo-enrichment, and network utility tools. So when you perform analysis on one of these tools that depend on utility services, part of the operation happens on your hosting server, and it farms out some of the operation to the utility services, which runs in ArcGIS Online. So when you are configuring these utility services, you will require ArcGIS Online credentials. And when these tools are used, it's going to consume credits in ArcGIS Online. So that is something you should be aware of when using or configuring these tools for performing analysis. The other option is to use utility services from your own server. At 10.4 and 10.41, we support configuration of elevation and network utility services on your own server. So for network utility services, it requires street map premium data 2015 release 2 or later. The reason is the data has to be in a certain schema for you to be able to create these network utility services. And ideally, you want to set up the services on a federated server or a server that's not your hosting server. Because when you perform analysis and it will make a call to these utility services, and you don't want these utility services to be running on the same server because it's going to compete for resources on that machine. One recommendation that we have is if you are using network or elevation data locally, we want to keep the data locally on the server machine rather than having it on a UNC share. It's going to affect the performance when the network tools have to access it over a UNC share. And we also recommend that you use a SSD drive for better performance. Another recommendation that we have here is that you set the minimum instance and max instance to be the same for the network and elevation services. What does that mean? So it means that these services are always available and running and ready for accepting any requests. If your min instance is 1 and max instance is 2, let's say there's 2 concurrent requests coming, one will be available readily to perform. For the other instance, it has to start up, and there's going to be some performance overhead there. And here again, you have to ensure that you have your max instance less than the maximum number of CPU cores available, because the network services are CPU intensive. Another aspect of spatial analysis tools that administrators should consider is who has the privilege to perform analysis. By default, administrators and publishers can perform analysis. You can also create a custom role and specify specific privileges in that custom role and add users to that role and allow them to perform analysis. I will show you a demo of why this might be useful. So here I'm in my portal. I'm going to my portal's organization page, and I have a few users here. So if I edit my organization, there is a tab called Roles. I already have an analyst role created, but for this demo, I'm going to go and create a new role. Call it Spatial Analysis or Demo. And then you have several templates to choose from, and there is an analyst template. Once you choose this, you can see there are several privileges that are shown here, and some are automatically selected for you. So by default, an analyst requires privilege to publish hosted feature layers. And you also see here, analyst is granted privilege to perform network analysis and geo-enrichment and elevation analysis. As I said earlier, if you're using utility services from ArcGIS Online, if you perform network analysis or geo-enrichment or elevation analysis, it's going to consume credits. So if you want to grant privilege for someone to do analysis on just the standalone tools, which don't require any utility services, you could turn these capability off when you're creating this role, and save the role, and save this. And then once you go to your users, you can assign them to that role. Now this user will be able to perform analysis, but they won't be able to use any of the tools that require utility services from ArcGIS Online. This is one way of controlling, who gets to use the tools that will consume credits, and so on. if you are an analyst who is performing analysis, there are several formats that are supported, which includes feature layers, CSV, shapefile, feature collection, KML, and so on. The key thing to note here is, for performance, it's always better if you already have your data as a hosted feature layer on that portal. There is no limit on the number of features that you can analyze if you're using a hosted feature layer as input to analysis. Also, when you use a hosted feature layer, the data is read directly from the database, and it performs better in this case. If your input comes from a feature service that's running elsewhere, there is a 100,000 feature limit. And also, the data will be downloaded by query, so it's going to perform slower. So this is something you should consider when you're performing analysis. About the output from spatial analysis. The output is always a hosted feature layer or a hosted feature service on your portal. The resultant data will get stored in ArcGIS data store. So you might think, is this going to be a problem when my analysts are creating hundreds of or performing hundreds of analysis and creating hundreds of feature services? The answer is no, because the hosted feature services that we have in Portal are scalable to support thousands of services. We have tested with like 40,000, 50,000 services on a server. But for management reasons, you may want to periodically clean up your services and the data behind it. So one way to do this would be to use the dashboard, which lets you see the usage of various services in your portal. If there are services that are rarely used, you could probably contact the owner of that service and have them review and delete that service. By deleting the hosted service, it will also delete the hosted service item. It will also delete the service and the data behind it. And that's all I wanted to share today. So in summary, there are, the minimum and maximum instance for the service, for the spatial analysis tools. You can adjust that to increase capacity. Utility services, how are you configuring it, whether it's from ArcGIS Online or your own utility service. And if you're using your own utility service, think about where the data is going to reside. And then when you're performing analysis, whether you're using a hosted feature layer as input or whether it's a feature layer coming from somewhere else. And then for the output, periodic cleanup of the service and the data. And that's all I wanted to share. And next, I think Jason is going to present. I can take questions in the end after we are all done.
All right. Okay, everybody hear me in the back there? No? How about now? Better? Okay, good. So we're going to switch over to my slides here. So we'll just kind of talk a little bit, then I'm going to do some demos. I'm going to go through all slides first. If anyone has questions, go ahead and stop me. But first, to open up, just a quick question would be, how many of you either are admins or are user who said, oh, my service is really, really slow. What's going on? How many of you had that? Okay, wow. Okay, a lot of you. So hopefully this will help you avoid some of that in the future. And if you do encounter it, learn why and how to get around it. So understanding the factors, that's really what you have to do. You have to understand that server it's a stack, right? Server, portal, your web application, it's what we would call a software stack. It's got components. You have your front-end application. Maybe it's a custom JavaScript app. Maybe it's portal. Maybe it's server, or maybe it's online or just online. And they go down through a web server, probably, and then into your GIS server, which in turn talks to data somewhere else. So you can see there's a lot of tiers. And each piece kind of has its own tool that you use to evaluate it, or sets of tools. That's really important. And generally, the rule of thumb is you're only going to be as fast as your slowest piece. So you could have the greatest CPUs in the world. They could be really fast. You could have a huge bandwidth connection. But if your database is never maintained and it takes forever to run a query, it doesn't matter how good that other equipment is, you're going to be undone by that slow spot. So that's the important part to kind of take away from this whole talk I'm going to do here, is that think of your server, whenever you're looking at a performance problem, always be prepared to break it into its individual pieces and look at each one. And we'll kind of go through how to do that at the end, but I'm going to talk about at each tier. But you can see the tiers up there, data, and then the map, and obviously then the different servers in the app. So data access. Data access is kind of what server's all about, right? We're putting data out there so users can access it in different applications. But the kind of data access I'm talking about here is the server has to access data in order to serve it. That makes sense, right? I mean, if you want to think about it, an analogy I've used before, we're up here in this auditorium and we have a laptop, right? And the overhead projector is projecting PowerPoint up on the screen so you guys can see it. Server is kind of like an overhead projector. It takes what's underneath and projects it onto the web for you. But if the content you're projecting is no good, it's no good. So that's kind of, if you think about it like that. So the one thing I want to talk about is make sure your data is really well organized. Get rid of, if there's data you don't need, and I'm talking about in a geodatabase or in file shares, folders, if you register a folder or server. If you have data in there you don't need, get rid of it. It may not slow the server down, but it's going to cause confusion and just general disarray. So get rid of it. Keep what you need. Keep all that data, that's fine, but take it out of your production space. Maintain your database. If you're using a database, maintain it really well. Make sure you're doing regular compress on the database. Make sure your fields are indexed and everything you're using is indexed and generally maintained. And generally consult. Everybody's got different databases, maybe SQL or Oracle or Postgres, or there's plenty of others. But consult the best practices from the vendor to make sure that your database is really tuned up. And a lot of you might have DBAs. So consult with your DBAs to say, hey, is this database all it can be performance-wise? Make sure that's being done. Test your queries that your server is going to make. Test them against the database, because if they're slow there, they're going to be slow in server. And then fast access, what I kind of mean there is, make sure that you have a really good network connection to your database. Make sure it's nearby. If you're pulling data in and your server's in San Diego and your database is in Houston, well, that's a long distance. It's going to be slow. There's not much you can do about that. So try to work from a geographical location that's to your advantage. And that's a recurring theme in this presentation with a couple pieces. So keep going here. So next up, you're going to author a map. And you want to author your map the best you can so it performs well. So basically, think of it this way. A common trend that we see a lot of users calling with, they'll say, my service is really slow. And then we look at it and there's hundreds of layers. And I'm going to have a demo of a service like this. Sometimes you have to think exactly what I have up there. More services, less layers. Publish more services, but put, if you're publishing a base map, or not even a base map, just a map of your county, let's say, don't put roads, parcels, power lines, parks, don't put all that in one service. Break it up logically. Maybe put roads in their own service, parks in their own service, and then use the application and let your users choose which layers to toggle on and off in the application, or just turn them all on in the application, but do it at the application tier. And then the server is able to dedicate more. Ravi talked about instances. So the server, you can get more instances spread out and divide the workload more evenly and get a little bit better performance. And you can optimize the performance of each layer. If one layer takes longer to draw, you can give it more instances and optimize it. Simplify everything. And we have great documentation on this as well that talks about how to simplify. Everybody, when you publish a service, you get the analyzer window, right? And everybody sees those warnings in there. And it's our tendency a lot of times just ignore them. We may just click, okay, next, nothing's red. Okay, it's got published, fine. But look at some of those sometimes and see. Sometimes they'll say, this type of labeling will draw slowly, or this type of symbology will draw slowly, and consider that. If performance is really important, take a look at that and see if there's anything you can adjust. And use queries, use definition queries. Don't publish more data than you need, basically, is kind of the bottom line. Don't publish 100,000 features when you need 10,000, because servers get to deal with all of them. So, okay, keep going here. The next thing, and we're going to be talking about this a little bit more, but fast, you want your config store to be fast. Is everybody familiar with the config store and what that does? Okay, great. So the config store, it was the main configuration for server, and this applies to the directories as well. You want those to be somewhere that's readily accessible to server. If it's a single machine site, on the server is good. If you have to put them on a share for a multi-machine site, you want to make sure, first of all, that share is very performant and has good read-write performance. You want to make sure, again, to come back to the geographic aspect, make sure it's close. I mean, I've seen cases where a customer would have their config store on a NAS device or a SAN device in another city. So then their server's having to go out through the internet to pull its configuration information. That's not good. It's bad. It can cause not just poor performance, but even some instability if there's an interruption. So avoid that. Then the next, in that kind of big switching of gears, you're going to look at the instances. And I'm going to demo all this in just a moment to kind of walk you through it. But you've got instances, right? And Ravi talked on it. You want to have the right number of instances. And I'll show you how to monitor that. But have a good number. Don't go really more than your number of cores. You can in some situations, but generally as a rule, stick to the number of cores. And observe the instance usage. And that takes some observation, but it's fairly simple. RAM, make sure there's enough RAM to support the number of instances. That's really what I mean here. The RAM, like David was mentioning before we started, just having more RAM doesn't make things faster. But if you're going to be adding instances of services, they're going to all use RAM. So make sure you have the RAM to support it. That's kind of what I mean here. And then another thing that's often overlooked is log level. Don't run your server on debug. Don't run it on verbose, really. Unless you're working with Esri support or something and we're telling you, hey, we need to look at some higher level logging, don't run it there by default. It'll slow the server down. And the whole server, not just a specific service. And then your web server, we're not going to talk about a lot here because web servers are pretty much a third-party technology. But if you're using a web adapter, you're using a web server. So make sure your web server is configured according to the vendor's best practices. If it's IIS or Tomcat or whatever, there's many of them. Make sure it's configured appropriately. And again, make sure a recurring theme, the pipeline between the components is good. Good that the web server and the GIS server are connected quickly and efficiently. And then finally, we've kind of worked our way from the bottom up. We're at the top of the stack. Application. So use the latest technology, whether it be an API or ArcMap or whatever your client is, a mobile app. make sure it's up to date. We're constantly, the different development teams are constantly making performance improvements to all the different pieces of the platform. So make sure you're using the latest and greatest to take advantage of that. Will always help. Make good requests. That sounds kind of weird, right? What does that mean? Well, make sure that the requests, again, I talked about don't publish more than you need. Don't request more than you need. If you're writing, an application that makes a query thoughtfully. Pick what you need to return and exactly what you need to return. Try to avoid picking more than you need to return. And make sure the requests work. Test them very thoroughly, because if you have a request with bad syntax, and it could be pinging the server and generating a lot of log traffic and just causing all kinds of noise that you don't really need. And you'll organize the layers. I touched on this a little bit before, but let your users have some choice in the application. Have the layers turn on by default that you need and leave some off, and things like that, and focus on that. And really, those are the main things. And then one thing that I don't have a slide on, but that's also really important, is we're talking about web stuff. So obviously, geography comes into play one more time. Clients that are farther away from your server are going to have a little bit more latent performance as they go over the web. So something to keep in mind. So that's something you may not be able to change. You may have your server in one office and have users in another office. You can't avoid it, but just be aware of it. Because it always helps when you're trying to explain to a user, if they call you and say, it's really slow in my office, and you determine, well, hey, it's really fast in my office. Sometimes you just have to say, hey, that's the limitation of the environment. So keep that in mind, and everything should be pretty good there. And let's go ahead and go on. And this is where we're getting into the demo here. So divide and rule out, divide and conquer, right? That's all you have to do. It sounds simple. We'll talk about it. They're calling it, say, poor performance. So identify the service that's performing poorly, exclude the application, exclude the web server, check the configuration, review the map, evaluate. Okay, let's get into the demo. Yeah. And let's go ahead and we can go over to go in there. And let's go ahead and go into this text file. Yep, that one. Yeah, we gotta get the app URL out of there real quick. Yeah, it's only a second. Just grab that URL and we can open that on the machine. I don't know, desktop and work it. Okay, awesome. So we're here on my Amazon Windows machine. So we're here this is on the Amazon Windows machine now. You can see I have ArcMap open. And did we pull out? No. Sorry about that. Uh-oh. I lost the video. Oh, do you have to push the button to send it up there yet? There it goes. Okay. So I'll just keep it over here. So we're here on the Amazon Windows machine now that I have set up for this demo. And basically, to set this up, what I did was I set up data and maps, the entire US street map and base map. Really, it's a US base map. So what that looks like, it's just a million layers. It's everything you would think it would be, right? So let's see. And here's my server manager. So you can Command V. So here's my application. And I just used the basic viewer template, real simple. I kept it simple for the purpose of this. So we're going to open it up. And you're going to notice a few things about it right away. Hey, some layers loaded real quick. And some layers didn't, right? Everybody could see that. And we'll pan and zoom, and I'll kind of show you what I mean. But you can kind of see, so my points, they're pretty simple. But you can see that the complicated stuff on the backside, it's complicated, right? It takes some time. So I've got layers here. You can see these are different layers. I did that for a reason. I did that to kind of demonstrate what I said about breaking it up. So I've got my cities and my airports, and those load pretty quick because they're by themselves. But it's this whole USA thematic map that, if we take these other ones out, it's pretty slow, right? I mean, you could see it's still loading up here in the corner. That's pretty slow. So what do? So for that, okay, now I have some video. Now I can show the videos. So I'm going to show you what that looks like on the back end. And I made videos because with the configuration we have, it's a little easier to show a video. So let's do the app load in Fiddler. So let's open this and play this video here. Basically what we're going to look at is, this is everything, and I targeted Firefox for this when I recorded it. And you can see here everything loading. And it loads, and these are all the calls that go on to load that application. Some of them are the applications, some are the services. The service requests are down here. And you'll see I highlight them in a second. And so you look, and what I do is I do a select all here. And then I go to timeline. And I look, and the smaller the bar, the faster it is. But you see there's a couple really big bars there, right? Well, there we go. Now we know what's slow. So if you double click it, there's the request. Well, that's an export map request. That's the basic building block of using a map service in an application, an export map request. Requests an image, it gets that. So that's it. That's what took a long time. So you could see here, all the bars for the application, they were tiny. The application's loading great. Your code's pretty much out. So now what you would do is you would go to the REST endpoint and repeat that same request. But you would take it a step further. You'd repeat that at the REST endpoint, and we can do that here. You can just open up that REST URL I have there. I was in that text file. Just open up the REST services. We can do it from here. It goes together. That's nice and easy. And you're going to see here real quick what I'm talking about. So if I go to REST services, and I go to the thematic map, and I just go to the JavaScript viewer, well, it's still pretty slow. So that tells me it's not my app. It's the service. So it's slow. So what we do now is, and I can't do it here because of the Amazon configuration, but next, we would assume it was going through a web adapter. This isn't because it's Amazon, but try it through 6080 or 6443. See if the problem persists. If it does, then you know, hey, my web server is running fine. It's not the web server. So then you got to get down a little bit further and look at instances. Now I have another video, and we'll go over here. And so play this first one here. Yeah, that'll work. So this is what a slow map service looks like when you're kind of using it, and we talked about this a little bit. And so we know, this is another example. I'm going to talk about now a little bit. Look how many layers are in here. 87. And it's drawing, some of them are scale dependent, but it's drawing most of them. Every time you make a request, every time you do that export map, server has to think about all of those requests. And then you get something like this, which we've seen, right? So that's what it looks like. You don't want that. You want to try to clean that up. And that's it. That's just a repetition. So now we can go over there. We can go to the next video. So now go to the instances video here. So we got instances. And, this is a small video. It's pretty small. So this is what that looks like in your server manager. One instance is running, one instance in use. And you'll notice as I pretend I'm panning and zooming right now. Use your imaginations. I know it's the end of the conference, but try your best. And you'll see eventually, 2 and 2. So you start seeing both instances are running, and they're both in use, and they're staying in use. So they're bogged down. So that would be a case for what Ravi mentioned earlier. Increase your instances. Go up more. Go to 3. Go to 4. Go to 5 if you have enough cores. And then keep repeating that and seeing how it's performing. And then go to the task manager one there. And this is what the same workflow looks like in Task Manager. So again, pretend I'm panning and zooming here. And you could see there's different. First of all, you could view the name of a service in Task Manager. I'm going to demo that in a second. But you can see my thematic maps, and there's 2 instances running. And you can see their memory goes up, but you can see their CPU number there in that middle column with the numbers that keep changing, it's bouncing all over the place. So you can see a lot of CPU usage. The instances are working hard. So again, that kind of indicates time to look at more instances. So we can back out of this. And then, yeah, and then basically to do that, you're going to want to make sure your tools are enabled in the task manager. And there's one more video I'm going to show. And this gets back to data. And this is a little out of order, but we're land speed test MP4, the one below it. There we go. So this is another one that we're going to show here. This is a land speed test. This is to speed test. And I had to do this recorded because we didn't have any network shares. But you put in a network share. And this is a free program that you can get off the internet. And you'll see you specify a file size. So I tell it to write a 20 megabyte file. It loads up in a second here. And so if this was where your config store was or your data store was, you could run this. And you could see it's going to do a quick test. Hey, it writes at 89, reads at 78. That's pretty good. But if that number was really small, yeah, I'm highlighting it there. If that number was really small, that's a performance bottleneck. So you'd want to either move it local or increase the speed there. And that's kind of the majority of those things. And then the only other thing, if we can go back to the Amazon machine real quick, I'm just going to talk about is, yeah, that's it. Cool. So I'm going to just do one more quick thing. So in Task Manager, actually, Task Manager is open, right? Task Manager, yeah. So you just want to basically go over to Details tab, and you'll right-click the Details tab and make sure that Command Line is turned on, because that allows you to, as I showed earlier, view the names of the services here in the SOC process. So that's great. You can not narrow it down. And then if we go up a little bit and close that out, we're done there. And that's basically the majority of the demo, but you understand what this map looks like. So you'd want to use scale dependencies. And I'm not going to dwell on that part now because we have really good documentation on it. This was just kind of a primer, and I can certainly take questions, but I think that is the majority of what I had. So, and we'll take questions again at the end, and I'm sure there's plenty, so we'll get to that.
Thank you, Jason. So the thing I'm going to cover is getting the most out of your file server. Now, you probably haven't had any other sessions the entire UC on file servers. And that's because the file server doesn't get any respect. I'm going to make the case for it that it deserves a lot of respect and that there's a lot you can do to improve the performance of your system by paying attention to your file server. So this is probably the only slide that you're going to see in the entire UC that has Kobe Bryant on it. So feel free to take a picture of that. But it illustrates a point. And this is the point I'm trying to make, is that the file server is critical. I mean, without data, you don't have anything. And all your data has to reside somewhere. The most popular place by far is to store your data on some kind of file storage device. Now, if you ask most people about a file server, it would be a complete mystery. They would tell you it's some kind of machine that I store files on. And I'd say, yeah, and how is it configured? And they'd say, is there more than one way to configure a file server? Because most people know nothing about file servers. They may hear the term NAS or SAN, but they really don't know how it was purchased, how it was configured. And they assume, well, a file's a file. Why does ArcGIS Server files somehow are different than other files, like Word documents? And the answer is they are different. And I'm going to talk about some of those differences. And a lot of times your file servers may be purchased by IT folks who don't know anything about GIS. And they aren't tuning it for GIS. And they'll find there's bad performance with ArcGIS Server because it's been configured for Word documents and not for GIS data. So it also turns out it's the engine. Like what happened is for years, our software looked better because the CPUs got faster and faster. And like, wow, look how fast ArcGIS Server is. Now, we also did lots of optimization too. But when it comes to hardware now, a lot of the advancements you're getting are from other components other than just faster CPUs, faster networks, and also faster file servers, as I'll show. Before we go in, I want to make sure we're all talking about using the same language because, like I said, this is a mystery to most people. So I'm going to introduce some terms here, and I'll talk about each of them on the following slides as well. So the first one is direct access storage. This is probably the one you guys all know, even though you probably haven't heard the term direct access storage. This is when you have a hard drive and you put it in your computer. So that's pretty simple. Now it's the standby, it's traditional, and the way the CPU communicates with it is through a little wire on your motherboard called a bus. I don't know why it's called a bus, but it's a little wire and it directly communicates into your hard drive, right? It's a very short distance for it to travel, performs very well. Now the way the CPU works with this hard drive is at the block level. Now you're like, what the heck's a block? A block is really just a group of bytes. So it's like little zeros and ones that are all grouped together. It's more efficient for the CPU to write a group of zeros and ones than to a 0, 1 here, a 0, 1 there, 0, 1 there. So it groups them together for efficiency, and those are called blocks. Now, it's also low latency, meaning that the moment it wants to get something from that disk to the moment it gets something back is very fast. And that's because it's traveling a wire that's centimeters in length. The next options are all remote options. The next two, the NAS, Network Attached Storage, and the SAN, Storage Area Network, are very similar in many ways. They're both dedicated devices for giving you storage. Most cases, they're in some server room, they're in a rack, there's a bunch of hard drives plugged into this device, and the main difference between them is how the CPU views them. A NAS, your computer is going to view it as a file. The SAN is going to view it like a block or a hard drive. There's a subtle distinction between them. So when you use a NAS device, the computer thinks it's talking to another Windows operating system or another Linux operating system, and that it's a Windows operating system that's sending a file. So it sends files the way Windows sends files. That's a little bit less efficient than the second method, the SAN. The SAN makes your computer think it's a hard drive. It makes it think it's the hard drive plugged into your system. It's not. It's going through a little Ethernet cable or a fiber optics cable that goes directly into your rack device. And it travels meters, but not centimeters. Now, these two are the best at scalability and efficiency. Basically, you can, if you need more hard drive space, you just attach more hard drives into your system. A lot of times you're sharing that SAN or your NAS with a bunch of other people. And if somebody needs less space, you can move it over to yours, or you can move some of yours over to theirs. And there's a lot of stuff that can be done there in terms of efficiency. Also, because these things are designed for lots of people accessing them, they have a lot of additional performance things that have been added, like flash RAM and other kinds of things, flash cache, that allows these things to perform really, really well for people connecting to them. And there's been a lot of advances in these areas over the last few years. As people move to virtual environments, you probably don't know this, but the hard drive on your virtual machine, almost all cases, is coming from a NAS or a SAN, probably a SAN. The last option is the remote computer. So this is just, I have a computer in my environment, I stand it up, I put some files on it, and I start sharing it. It's nice and simple, and that's why a lot of people use it. It's great. The files are also accessed over the network, and they're accessed to the file level because it's just a file server. And it's the simplest network solution, which is why a lot of people use it. Now, it doesn't do much good to tell you there's a bunch of options, but if I don't tell you which one performs the best. Now, I'm going to tell you which one performs the best, and that's obviously direct access storage with solid state drives. Now, I'm going to tell you why, and I will also acknowledge that this may not be the option you choose, because performance is not always the overriding factor. Sometimes you have to balance performance with cost and other things. So, now direct access storage with SSDs, the reason it performs so well is because our software is highly dependent on the latency speed. So there's different types of access, if you've ever thought about files. Sometimes you're loading up huge chunks of terabytes of data, and you're reading it sequentially, and you're reading it byte by byte, and you're going through, and you need something called high throughput. With our software, especially ArcGIS Server, you're getting a bunch of requests coming from all over, and they're looking at different parts of the world or different parts of your geography. They're looking at different layers. There's a lot of what's called random access. And there's a lot of small chunks. They may not seem like, it may seem big, like you're 10 kilobytes, but that's actually very small in the disk access world. So there's lots of these small writes that are all over the place. And so systems that have low latency perform really well with ArcGIS Server. So that is going to be, direct access storage. Like I said, low latency. There's a short wire between your CPU and your hard drive. Solid state drives, we haven't talked about those yet, but those do really well with low latency reads. And this applies to pretty much all the GIS data you can think of, whether it's a file geodatabase, a shapefile, the tiles that you cached from your map service or mosaic data set, even with Portal, your story maps. All this content, they're going to be short, small, random access reads. Now, there's obviously reasons you might consider things other than direct access storage, and we'll give you the guide for those other options. Now, you obviously might not choose direct access because of money. I mean, a lot of us, we know GIS data can be huge. You may not have the ability to, or the money to afford 50 terabytes of storage in your local hard drive. That may not just work for you, especially if you have 10 ArcGIS Server machines. If you have 10 ArcGIS Server machines and you want direct access on 10 of them, and you have 50 gigabytes of data, you're going to need 500 terabytes of space, 50 for each machine. That gets really costly. The second thing is the data being too big. With SSD drives, if you buy them, they're between 1 to 5 terabytes in size. They're not necessarily jumbo size at this point. And you may need to consider putting lots of SSD drives together. And you only have so much space in your computer system. You may need to put it into a rack-mounted system. There's effort. Like if you have multiple ArcGIS Server machines, copying the data locally on 5 machines is a bit of a challenge. The other thing is the last option, or last problem, which is redundancy. I don't know. Has anybody ever had? I don't know if anybody's ever had this problem where you're looking at your maps, and every fourth or third map has something that's wrong, and it's outdated data, it's stale data, and you see it, and you're like, okay, one of my machines has outdated data, but figuring out which machine that is really hard, because when you're connecting to it, it's being load balanced, and you don't know which machine is going to it, and there's nothing in the logs that says your data is outdated. So hunting down outdated data or stale data on your machines can be quite an effort, and so that redundancy can really be a pain. So let's talk about the remote storage options. So, the performance chance when it comes to remote storage, the file server, where you just stand up a machine, that's the slowest one. The SAN and NAS will usually outperform that. They cost more money, though. So the SAN is going to be faster than the NAS in general, because SANs are doing at the block level access, and that's usually more efficient. They both scale well. They both can provide high availability. Now, the thing with SAN and NAS is, and this surprised some of my coworkers, I think they went to a Best Buy and they saw a NAS device for $200. When I told them how much NASs and SANs actually cost, they didn't believe me. They said, no, you got misquoted. But we actually went through this process of buying I asked the IT staff to heavily involve me. We bought a NAS device recently. And these devices cost tens of thousands to hundreds of thousands of dollars. And my colleagues, but they're just hard drives. And that's, again, this mystery of the file server. They're just hard drives. But they're configured in ways that make them perform very well, that provide high availability, that have advanced features like multiple controllers. They have flash cache and a bunch of other things that justify the cost. That thing that you buy at Best Buy for $200 does not do any of those things. It's a glorified external hard drive. So this thing, they cost lots of money. The big advantage to that remote file server is you can buy files. You can buy just a computer, right? A server for your server class machine from $5,000 to $10,000, and that's a lot cheaper. But it doesn't have the high availability. It doesn't have the optimization for performance. The other downside to SAN and NAS is this is like a black art. Like there's an IT guru. Even within the IT department, there's not a lot of people who would consider themselves experts on file storage. And I worked with our file server expert to learn a little bit and glean some knowledge from him over the last year. And there's a lot of subtlety in knowing about these various protocols that you can transfer data, how to buy the machine, how to size it properly. And so you need to have an IT guru. Now, I'm not going to tell you how to do that because hopefully you have that in your organization at some point. We also talked, and this is almost an obligatory slide. I think this is well known. But the old traditional type of hard drive you have, the hard disk drive, they're spinning around like a record player. They spin around between 5,400 times per second to 7,200 times per second. Some of them can spin around 10,000 times per second. But basically, the more they spin around, the faster your access. But there's a limit to how fast you're going to be able to spin a metal or plastic disk around, right? So these things are inherently limited to how much data they can get. And a lot of times it's finding the data that's really slow. But they have been less expensive. And SSDs have been gaining traction because you don't have a little mini hard drive in your phone. You don't have a mini hard drive in your iPad. You have solid state drives. Because one of the things is those hard drives are not so robust when you're throwing them around or they're being bumped around in your purse or whatever. You need solid state drives. They handle the daily grind a lot better. So SSD drives, because of this mobile revolution, have become a lot less expensive. There's a lot more benefits to mass production. So now let's get specifically to some of the recommendations for ArcGIS Server, and primarily Server. Portal, we're not hitting too many performance issues. Now there's two areas of ArcGIS Server where people talk about performance. One of them is the data, which I'll talk about second, and the other are the settings. Because believe it or not, the settings have a big impact. And the place where we store the settings are in this so-called config store. Now, the reason historically that the settings have mattered so much is because every time you access an ArcGIS Server service, we need to check the permissions. We need to make sure, even if it's public, we need to make sure that that service is publicly accessible. Or that, no, does Amy have access, does Bob have access to that map service? So that check is very time-consuming when you have lots of users, because it's going out to a file, it's opening that file up, and looking at the reads. That's how 10.1 worked. Every time you came in at 10.1, we checked the file. And it worked, but it was slow, especially when you had tens of thousands of people accessing it. And over this last 8 releases, we've done optimization after optimization to optimization. The way it works at 10.3.1 or later is the first time somebody accesses a service, we read in the permissions, we store it in that server, and we cache it. We keep it in memory. We don't go back to the file. We keep it in memory for a certain amount of time, a few minutes. So then there could be 30,000 requests in those 5 minutes, and we're not doing any file access there. After the 5 minutes expire, we go back and check again, just in case somebody's changed permissions. So at 10.3.1, you might sometimes see, boy, the permission is not taking effect right after I changed it. Give it 2 or 3 minutes, you'll see it take effect. But that's buying you a lot of performance, and that's one of the changes we made. So if you're seeing slow performance, a lot of times people in support will say, we'll try a later version. And it's not just something they're saying. It really does make a difference. We made some big optimizations in this area. The second thing is DFS. So I had it on a slide earlier, but I've saved explaining it until now. Microsoft has a great technology called Distributed File System. And it's a fantastic technology that Microsoft has. But it does not work well with our config store and our settings. The way that DFS technology works, it's very nice. You can have many file servers around your company, around the country. And when you go access them, they all have the same names. // mydata.esri.com. And you put in a name, and it will figure out which file server you should go to. So like for instance, at Esri, we have our software setups for ArcGIS Server, Portal, Pro, ArcMap. We have all these setups on a file share. But everybody in the whole company uses the same location to get it. But if you're in Washington, D.C., you're not coming back to Redlands to get it. We have a file server in Washington, D.C., so the D.C. folks don't have to wait an extraordinarily long amount of time for that data to be transferred across the country. But DFS makes that transparent. Now, the problem that we have with DFS, with our software specifically, is DFS is not intended for what we're using it for. DFS is intended for people who have like Word documents. Like I put it out there, and I put it on one file server, and then Microsoft's file replication service will copy it over to the other machine in its time. It might take a minute, it might take 2 minutes. But it will eventually copy it over to those other machines. The problem is we have this demand that we call immediate consistency. We have a bunch of machines, they're all writing settings to a remote location, and once one machine writes down the setting, it tells the other machines, hey, other machines, we've just published a service. Go to the config store and get the settings for that service. And sometimes those other machines don't get sent to the computer where the write happened. They're sent to the other machine that hasn't got the update. And that slow replication causes problems. And so sometimes you'll see issues with publishing, for instance. So for config store only, we don't recommend DFS. It's fine with data. But for the config store, we don't recommend it. And you talk to Microsoft, and they just said, yeah, it's not for the purpose that you're intending it to be, this high transaction editing type server. It's designed for somebody who's placing files out on a thing to share with the whole company. At 10.4, another thing you can do is we introduced a mode called read-only mode. And that's mainly for change control. Like sometimes when you have your ArcGIS Server site, you're thinking, you know what, I'm not going to be making any changes on it for a while. I'll put it in read-only mode. When we need to make a change, we'll take it out of read-only mode. And it's a way that the administrator can keep people from publishing, other administrators from doing stuff. It's kind of a way to let's have some control so we're not messing with the server while it's live and lots of people are using it. We're going to do it on Thursday night when everybody's gone home. That's when we're going to make our change. But it has one other benefit. The way we implemented that is in read-only mode, we know that the settings aren't going to be changing. So we don't need to have necessarily one authoritative location on a remote location. You have lots of machines. What it will do is it will copy it locally to each machine. And each machine will have that locally. Remember, I said direct access storage is faster. So that will also give you some improvements. Finally, there's this last option, and it's another technology that Microsoft has called OPLOCks, opportunity locks. Opportunity locks, the locking of files is, I won't get too geeky about it, but one of the biggest problems with multiple people editing files is you have to make sure that Amy's not overwriting Bob. And with opportunity locks, Microsoft said, well, we can make the locking a little more efficient. The way that most people use Word documents, there's only one person editing it at a time. We'll just assume that we're the only person locking it. We're not going to keep going back to the file server to say I'm locking this or unlocking this, because that's really time expensive. We'll just tell the remote system, hey, if somebody else needs to edit it, let me know and I'll leave the OPLOCks mode, and then we can do our normal locking mechanism. So it's an optimization that works really well with Word documents. It does not work well when you have a bunch of machines in a multi-machine ArcGIS Server site writing to the same settings files. It kills performance. It actually has a worse effect. And most of the time you talk to your file server administrators like, but it's supposed to improve performance, and it does with Word documents, with the setup programs that you're putting out there, but it does not work well with the config store. Now, the last recommendation I have will be with regards to ArcGIS Server's data. So there's a few things here. Some of them will probably be well known, some of them will be new. File geodatabases are faster than shapefiles in general. I'll see there's a few people who disagree with me, but when we've done our benchmarks, we see huge improvements over shapefiles with file geodatabases. Second, this one's not well known. Put your file geodatabase in a read-only location. Here's the reason why. First of all, you're having ArcGIS Server serve it out. ArcGIS Server never changes your file geodatabase. If you need to do editing with ArcGIS Server, it needs an enterprise geodatabase. It can't write to file geodatabases. You shouldn't be editing a file geodatabase in place anyway that ArcGIS Server is reading. And then this will turn off the file geodatabase's locking mechanism. It's always worried that somebody's going to come along and edit the file geodatabase. So it's like, hey, I'm reading this. Don't edit right now. And it's because it's putting these little lock files on, it slows it down. By putting it in read-only mode, it says, oh, I don't need to worry about somebody editing it. It's in read-only mode. So it's a file system operating system. Just take away write permissions for the ArcGIS Server account, and you'll get much better performance. Another thing is in your feature classes themselves, We support very high resolution data. But the reality is a lot of times when you're collecting the data, your accuracy may not match the resolution of the data. So if you've been to geodatabase presentations, they probably harped on this. But we have sub-centimeter resolution, and you do not have instruments that are capable of necessarily getting it down to that centimeter level. So make sure your resolution matches. You'll see big performance improvements. And then the last thing, and I know I said before you don't necessarily buy new RAM unnecessarily, and I'm not going to eat my words because there are some cases where it really does matter. The operating system will try to make things as fast as possible. So Linux and Windows are really smart in this way. They have something called system cache. They'll notice that certain files are being read a lot from disk. What they'll say is, you know, I have some spare RAM. Rather than make them keep going across that little wire on the motherboard or across the network, I'm just going to load that into memory and keep it in spare RAM that I have. And that is the fastest access you can have. And so that system cache, you don't have to do anything. The operating system just does it automatically if you have spare RAM. Now, if you're close to your maximum, it's going to say, I better keep it in case they start some more programs. But if you have like a 16 gigabyte RAM machine and you're using 10 of it, it will definitely be using some of that. And you're going to see better performance. That's one of the challenges we have when we do performance testing is it's sometimes hard to compare apples to apples because sometimes it's been loaded into system cache. And sometimes it's not. And so that skews our results. So we have a bunch of methods to handle that. And with that, I think that's going to conclude the major portion of our session. Why don't we take 2 or 3 questions, and then we'll just take the rest of the questions up here. I want to encourage you guys to fill out the surveys on our app. And I have business cards up at the front. I want to encourage you guys to contact us. It's really good for us to understand what you're doing, what tips you have on performance, what problems you have run into. And we really appreciate you coming to the user conference.